In this video, I will show you how to perform energy cutoff and gas spacing convergence tests in VASP using graphical user interface, and also how to automatically create POTCAR file for your corresponding POTCAR structure file. To do that, we will use a Streamlit application that you need to compile, and you can get to the link if you navigate to this website. And then here also. And then if you open the GitHub page, let me open this link. There is a short tutorial how to compile it. So let me quickly do it, and I will open my console, and I have an empty folder, so I will compile the code here. So first I need to download this code. It will take a few seconds. Okay, it's done. Now I will open this folder, and now I will create a virtual Python environment to prevent some errors between different package versions. So let's create a virtual environment called like this. Then I will activate this environment. Okay, then activate. And now I will install all the required packages to run this code. So pip install our requirements, and the required packages, if you want to see, are these. Okay, this will take maybe a minute or two. So let's wait. And after the packages are installed, I can already run the application. So what I will need to try this is to set the execution command that I have for my compiled VASP, and I can also specify the number of processors. Okay, so it's finished. Let's start it. Streamlit run app run. And now if I open this localhost link, yeah, it will open the application. Okay, so to create automatically the POTCARs, I need to set the path to the potentials. Okay, so let me do it. I need to open new Ubuntu to navigate to my folder. So my potentials are in this folder, and to use it, I need to go to the PBE, and this is the folder that I need to set here to automatically update the potentials. Let me copy it. Okay, so this I will just copy here, and I will set this path permanently. So whenever I will start again this application, the path will be automatically loaded. And then I need to set the execution command that will be used. So in my case, what I have now is VASP std, so I will use that, and with 4 processors. So again, I can set this command permanently. So whenever I open it, it will be there. I'll show you. If I stop this application and I will rerun it, rerun this link, and you can see the path and the command is there. So now I need some input POTCAR file to be able to use this code. So I prepared an folder, empty folder with just the POTCAR structure, which just as an example, it's entities, and let's upload it here. Oh, okay, sorry. I need to call it as VASP or POTCAR. Uh, for some reason, maybe let's call it POTCAR. Okay, so let's do it differently now. Uh, check this later. So I will rename this back to POTCAR. And now I will navigate to this folder. So it's annotates, and it will automatically, if there is a POTCAR file, it will automatically load it, as you can see here. So I can select if I want to do convergence test or k-point sampling, or if I just want to generate like the POTCAR file, I can do it here. And you can see it automatically created the POTCAR with these potentials it found for oxygen and titanium, and it is in a correct order as it is defined in the POTCAR file. So then you can simply download the POTCAR if you want, or you can also, when you prepared like the convergence test files, you can also download them here as well as the POTCAR, but that is already in the folder. And uh, for the convergence test, uh, you can, if you wish, you can add some other parameters that will be used in the test. For example, you can include spin. And just to quickly illustrate how this works, let's now perform very quick convergence test, for instance, with up to 500 ECAD and like k points 111, and now I can run the test. So it's running, and to see that, you can go to this live console, and it will show you like the current step and all the information that is normally shown in the log file. And you can also preview the results of the convergence, and this is also shown like during the calculation. So if I increase, or let me do now the k-point sampling to show it. So I can set the k spacing, the start k spacing, the end k spacing, the step, and the corresponding ECADs to be used. And this k spacing is automatically recalculated to the Moncourse pack grid for the start grid and for the end grid. So I can decrease the settings like this now, and let me run it again. So it's you can see live console how it's working, at which step it is now, and you can preview the live basically calculated results. So now it calculated only one step. Here you can see it skipped basically a few steps that give the same um, basically k points grid, and yeah, it finished the second point. So now you have here 2. And what I mean by this is that I set here the cast spacing step in the like cast spacing size, and but the corresponding k points grid was rounded to the same like number for the worst settings basically, so it would give the same energy, and that's why it skip it in the calculation. And yeah, so now I can preview uh, how the convergence is doing, and I can choose the settings based on that. If I want, I can stop the calculation with this button, and it's always running from the worst settings to the best settings. So okay, so I think that's all. And if I stop it, it should stop uh, once it will finish the current step. And this I will probably change to stop it immediately. Okay, so thank you for your attention, and I hope you will find this useful.